All right, I'm going to try and do this fairly quickly, although there are 100. So I think I'm going to make one video for the first 50 and another video for the second 50. So this first video is going to be on writing formulas if we're given the name. Now this is mixed naming worksheet. This was your homework for last night. And so it is a combination of covalent, ionic, and acids. So let's start with the first one. First one, NO2. If I look at that one, I say, all right, nitrogen is a nonmetal. It's not hydrogen, so I'm going to need Greek prefixes for this. Nitrogen only has one. We don't use the prefix mono when we're talking about nitrogen, so this is going to be nitrogen. Doesn't need mono, but we do need to say that we have two oxygens, so this is going to be dioxide. Greek prefixes are important when we have covalent compounds. Second compound is ionic. When it's ionic, it's a metal and a nonmetal, or a metal and a polyatomic ion, or a polyatomic ion and a nonmetal. So NaBr, the metal is sodium. The only thing we need to ask ourselves is, does sodium need a Roman numeral? Sodium does not need a Roman numeral, so we move on. The second compound is bromine. When it's a compound, we need to change the ending to bromide. So remember that if your compound ends in an element, in a nonmetal, then you're going to end the name with IDE. SiO2. Silicon, if you look on the periodic table, silicon is to the right of the staircase that divides metals and nonmetals. Silicon is a non-metal. So this is a covalent compound. We need to use Greek prefixes. Again, there's only one silicon, so we don't need to say monosilicon. We just say silicon. There's two oxygens. So just like before, this is dioxide. When we look at the next one, it is also a covalent compound because phosphorus is also a nonmetal. Only this time we have two phosphorus atoms, so we need to use Greek prefixes for both of these elements. So we're going to have diphosphorus because we have two phosphorus atoms. 4 is the prefix tetra, so we're going to have tetrabromide. Number 5. Now iron is a metal, so we're again back to an ionic compound. So ionic compounds begin with metals. We begin by writing the name of the metal, and then we ask ourselves, does iron need a Roman numeral? If you look on your periodic table, iron is not part of group 1, it's not part of group 2, it's not part of our staircase of 6, and so iron does need a Roman numeral. So we're going to put a Roman numeral holder right there. We're going to put those brackets or those parentheses just to hold our thought so we don't forget to go back and do it. And then we're going to look at the second part of the name. The second part of the name is a polyatomic ion, that is sulfate. So it's going to be iron, Roman numeral, sulfate. Now we have to decide, well, what is that Roman numeral? So to do that, we start on the right-hand side. We look at sulfate. We only have one sulfate here. If we had more than one sulfate, remember we'd see sulfate in parentheses and a subscript outside that parentheses. So we have one sulfate. Sulfate has a -2 charge. That's a total of -2. So our positive charge has to be +2. We only have one iron, so it's going to have the whole charge. Iron 2 sulfate. SF6, we're back to a covalent compound because sulfur is a nonmetal. There's only one sulfur, so we don't have to use a prefix mono for that. So we're going to call this sulfur. The prefix for 6 is hexafluoride. And our name has to end in IDE. All right, so now we have our first acid in number 7. We recognize that it's an acid because acids begin with H. Acids that have a polyatomic ion after the hydrogen do not get the prefix hydro. So HNO3 is our acid. NO3 is nitrate. The stem of nitrate is the NITR. We're basically going to take off the ATE. And remember that if it's an ATE ion, we replace the ending with ic acid. So HNO3 becomes nitric acid. Li2S is going to be, this is a ionic compound. So lithium, we just name the metal. Does it need a Roman numeral? It does not. So then we just name the second part of the compound, which in this case is going to be sulfide, IDE. It ends in an element, not a polyatomic ion. HCl, now we're back to an acid. When we look at HCl, we have H followed by a nonmetal, not a polyatomic ion. So we need to use the prefix hydro to indicate that we have an element, just a nonmetal, not a polyatomic ion that follows our H. So hydro, the stem of chlorine is going to be CHLOR, and then we end it with ic acid. So hydrochloric acid is number 9. Number 10, magnesium, it's a metal. Ends in bromine, which we need to write as a negative ion bromide. N2S, covalent compound. Nitrogen is a nonmetal. We have 2 of them, so we're going to write dinitrogen. We have 1 sulfur. We have to indicate that. So the only time we don't use mono is if the first element it only has 1. But if the second element in a covalent compound only has one atom, then we have to indicate that by saying monosulfide. Okay, that's an easy one to mess up on, so think about that. The next one is also covalent. Selenium. Oops, almost missed that. Difluoride. We have 1 selenium and 2 fluorines. All right, next one is also a covalent compound. So this is going to be arsenic. We have 3 chlorides, so trichloride. Next one is ionic. Barium. Does barium need a Roman numeral? Nope, it's in group 2. So barium does not need a Roman numeral. We just keep moving on. The second thing right behind it is chlorine, so we're just going to call it barium chloride. Next one is also ionic. Potassium. Potassium does not need a Roman numeral, so potassium sulfate. All right, now we get to one with a polyatomic ion and also one that is going to require a Roman numeral. We have a metal and a polyatomic ion. The metal lead is not in group 1, it's not in group 2, it's not in our special little staircase of 6, so therefore it must have a Roman numeral. So we're going to write the name of the metal, lead. We're going to look here, this is chlorate, so we're going to write parentheses so we can remember to go back and find the Roman numeral, and we're going to write chlorate. Now, to find the Roman numeral, we have to come back to the formula. We start on the right-hand side. Chlorate has a charge of -1. We have 2 of them. That's a total negative of -2, which makes our positive have to be +2. We only have 1 lead, So that one lead is going to carry all the charge. So we're going to have a lead +2 or a lead Roman numeral 2 chlorate. All right, we're back to an acid in number 30. Number 30, the polyatomic ion is phosphate. So if it's phosphate, the ion ends in ATE, so our acid is going to end in ic acid. And because it is a polyatomic ion that follows the hydrogen, we do not use the prefix hydro. So we simply take the stem of our phosphate ion, which remember for phosphate or phosphorus, the stem is going to be phosphor. So we're going to say phosphoric acid. So this is phosphoric acid. And NF3 is going to be nitrogen trifluoride. TiCl2. Ti is a metal, so we're going to write the name of the metal, titanium. We think about where is titanium. Does it require a Roman numeral? And yes, indeed it does. So titanium, we're going to make a space for the Roman numeral. Chloride. In order to find out what goes in the Roman numeral, we come over here to our formula. We say, chlorine or chloride has a charge of -1, and we have 2 of them. That's a total -2 charge. That means our total positive has to be +2. We only have 1 titanium, so it's going to be a +2 charge. All right, this is a polyatomic ion we haven't used in a little bit, but it's a polyatomic ion that we have to know. So aluminum is our metal. Aluminum is one of our elements that's in our staircase of 6. So aluminum always has a charge of +3. It does not need a Roman numeral. So I can move on. HPO4 is hydrogen phosphate. So the name of that compound is going to be aluminum hydrogen phosphate. Now we get to an acid. BrO3 is bromate. So it's ATE. So we take the stem, which was going to be brome. We're going to just say it's going to be bromic acid. No hydro needed because it's not an element that follows the H. It's a polyatomic ion. Same thing with IO3, HIO3. IO3 is iodate. So this is going to become iodic acid. On the other hand, when we look at 36, 36 is also an acid, but 36 is an H followed by just an element. So this is going to be hydro. Okay, we need the hydro because that tells us that an element follows the H. Hydrosulfuric acid. So the stem of a sulfate is, or the stem of sulfate or sulfur is sulfur. All right, Si3Cl9 is, we're back to a covalent compound. So it's going to be trisilicon nonoxide. So one thing we've talked about is that if you have 2 vowels, you can drop the first vowel. So it's nona is the prefix for 9. Nona oxide, I drop the A. Okay. Last one on this column, calcium. We ask ourselves, does calcium need a Roman numeral? It does not, so we move on. P is phosphorus. If it's a single element, We're just going to call it phosphide. All right, so I've talked for 15 minutes. I've done 38 in 15 minutes. I've posted the entire key for this. So take a look at the key. Check your answers to 14 through 50. Give those a shot. And I'm going to make a separate video for the backside where we're writing formulas from names.